Next page. Second page of the practice exam. I've been recording videos all day, so I'm feeling a little sassy. Alright, so this is problem number 4. In the absence of friction, an object dropped near the surface of the earth experiences this constant acceleration. So what does this actually mean? Well, the derivative of the distance? No. That would be the double derivative of the distance. The object falls 9.8 meters during the first second only? No. You want to check that one? Check this out. X equals 1/2 times 10 times 1 squared. Oh, it only falls like 5 meters, so that doesn't work. 9.8 meters each second, that would be constant velocity. The speed of the object? No. The only one that's left is this. And what this means is that the speed actually does increase by 9.8 meters per second each second. Ooh. Question 4. A ball is thrown on a parabolic path is shown. The air friction is negligible. So what is the acceleration of point Q? Believe it or not, it's straight down. And let's be clear. In the x direction, the equation is v0 cosine theta t, right? Plus x0. And in the y direction, it's y equals negative 1/2 gt squared plus v0 sine of theta t plus y0. So we only have acceleration in the downward direction, but this is actually true even at point P. The force on the ball is caused by gravity pulling down on it, so the only force is gravity downwards once we let it go. So now we have a spring-loaded gun that can fire a projectile. Oh, this is so much fun. So here's the thing. Let's say we launch a projectile with speed v, and it gets up to a height h. So it turns out if you want to find that launching speed, drop it from a height h and calculate its speed when it hits the ground. So we'll actually do that now. So v when we hit the ground, v squared is v0 squared plus 2gh. That's just y minus y0. So its initial speed is 0. So its speed when it hits the ground is square root of 2gh. Now let's play this in reverse, but launch it at 45 degrees. So if we launch this at 45 degrees, we're going to say vy squared equals v0 y squared plus 2g. And this new height that we get up to is what we're going to. So the initial launching speed is going to be square root of 2gh times the sine of 45, which is root 2 over 2, and then we square all that, okay, and then we reach a speed of 0 at the top, plus 2gh nu. I'm only interested in sine here. And actually, I guess I should be clear. We should say minus 2gh since downwards is negative. So we have downward gravity acting. And so when we solve for h nu, we're actually going to end up getting 2gh nu equals 2gh times 1/2. And so when I simplify, I'm getting half the height as my answer. All right. So let's go ahead and take a look at problem number 8. So we have two objects, and we want to know what's the relationship between the distances as they fall. So A falls for time t. Let's get its falling distance. So dA equals 1/2 g times 1 squared. dB, well, we're falling for 2 seconds. So g times 4, that's 2 squared. So I'm actually getting that dB is 4 times dA. All right, let's finish this up because we can. Problem 9. Where do we have 0 acceleration? This is a velocity graph, so it's wherever this is flat, here and here. So PG and TU. Oogly. Now, for number 10, this is a velocity graph. Let's look at this position graph. And the way we'll sketch this is we'll stitch together some of those graphs that we had like we did in the stacks of graphs. So I go forward like this. Then I go at a steady speed. And then I actually go forward and level off in speed. So let's find the one that looks the most like that. That appears to be choice D. So there's the multiple choice section completely done. And we'll work on the favorite response in the next set of videos.